Hello, today we are going to talk about the programming language, and we're going to take the language tour. Okay, so a quick recap. What is the programming language? It's this wiki page, programming language, 2001, Walter Bright, Andrei Alexandrescu, the official website dlang.org, 3 compilers, DMD, GDC, LDC. Let's go to dlang.org. So from there I went to downloads. I have downloaded the DMD reference compiler official download. I went for Debian tarxz. I downloaded this file. It's this one. I've extracted the file to tilde/.opt/dmd2, and then I went to resources, IDEs. I selected this IDE, DexEd. I went to its GitLab web page and I downloaded the binaries for Linux 64-bit. It's this file, and since the DMD executables reside in this directory, so tilde/.opt/dmd2/linux/bin64, I've also extracted DexEd, all of the files in DexEd, into this directory. Okay. The next thing I did is DexEd would not start without setting LD library path environment variable, and DMD could not run because it is not in the path environment variable. So for that, I have created a bash script file, which is called prefix.sh, which exports LD library path and path environment variables with the directory where the binaries for DMD2 exist on my machine, prepended to the existing values for these environment variables. So let's see how I do it. I open a console, which is the terminal. I'm on Kubuntu 22.10. The first thing that I do is I source this file. So what do I do? cd I go source, then prefix. I check that the environment variable path is set correctly, and it is. It starts with that directory where DMD is installed, and now I can start those executables. So the IDE, DexEd, DMD, and dub, which is a package manager and also manages the project. So the project format and the dependencies for the current project, builder for the project, runner of tests, etc. Okay, the next thing that I want to do is I want to go into this directory, which is tour, and in here I want to create a dub project. So how do we do that? The language dub, I search on Google, and I find getting started with dub.pm. So the official website for dub, DUB, the language's official package manager, dub.pm, says I should do this. but I don't want the project to be named my project. I want it to be named tour. I need to select between JSON or a SD-lang domain-specific language. So I'm going with the default, which is JSON. Name tour. Doesn't matter what description. License. I see in here boost. This is the license that's used for DMD. Let's go with boost. Space. Okay, I changed to the Tor directory. So this directory. In there, there's one single source code file, which resides in the subdirectory source, and the file name is app.d. It's a simple hello world project and file. And the dub file is in the top directory, top level directory. It's called dub.json. Has this content, whatever I gave as data entry to the dub init tor command line. And there's a git ignore file, which actually ignores the /tor, which is actually the executable for Linux generated when we build this dub project. So let's build it. So I should go dub build. Okay, and now I have the Tor binary locally. So this binary is the result of compiling this project and is an executable. I can execute it like this, and it writes on standard output what it should write on the standard output. Okay, the next step that I take is I start the ID, which is called DexAdd. I close the existing projects. Okay, and I open the existing project. Let's background it. Ctrl-Z, BG. Project. Open project. And in the Tor directory, where is that? It's called dub.json. That's the file that it wants to open. It says dub.json in here. Open. Okay, so there's just one source file. It's called source/app.d. Let's open this thing. And we don't want the build configuration plain. We want the build configuration debug because we want to debug this thing. Okay. Let's make sure everything works. File save all. Project build and debugger start. It breaks at the correct line. Where are you? We go continue and it exits successfully, and it says on standard output edit source/app.d to start your project and a full stop. Okay, now that we have an ID, let's put the documentation, which is the tutorial that we want to run through. To make the tutorial, use the left hand half of the screen. So it says tour.dlang.org. Interactive tour gives an overview of the powerful and expressive language which compiles directly to efficient native machine code. High level constructs, great modeling power, high performance compiled, static typing, direct interface to operating systems, APIs, through good interoperability with the C programming language, fast compiler, safety, C-like syntax similar to Java, compatible with C application binary interface, some compatibility with C++ ABI, imperative, structured, object-oriented, generic, functional, pure functional, assembly, contracts, unit tests, etc., etc. Okay, so we're encouraged to follow this tutorial and use the integrated in web browser syntax highlighting, runner, formatter. We can also edit the source code. Okay, so it says hello world 2 here. But we'll try to run these examples in our IDE because there we have debugger and we can inspect, we can step into, we can look at the definitions, at the implementations of the functions which are defined in the standard D library, etc. Okay, so let's see how we resize these things. Something like this. Okay, so let's take the first example, copy and paste. Control S, file, save all, projects, compile, and debugger. Where are you? Let's put a breakpoint in the debugger. Start. Okay, so right line hello 2. Let's see how that goes. Just a second. Okay, step over. So this is a function that writes to the standard output, similar to Turbo Pascal, Delphi, C#, etc. And it lives in the module std.stdio. And this is the definition. So std.stdio, and the function is named writeln, so writes and then puts a \n at the end, similar to echo in bash. and receives two things. One is a list of types. Take this. And the second thing is a list of values. So these are the parameters, and these are the type parameters. Okay. So what does the function do? The function starts with its signature and then its body. On top we have the doc strings, which are used to generate the documentation, which documentation is this thing, dlang, and then write-ln. Okay, so equivalent to write, but it also adds a \n. Write-ln without arguments is valid because it just prints the \n to the standard output. Okay. There's this example here. Okay. A bit of cleanup, just a second. And back to where we were. So the call stack is our function, which is main, and this is the name, the symbol main but mangled, and then that has called the function from the standard library, so tila/opt/dmd2/src/probo/std/std.io, stdio.d, and the function is called write-ln of immutable char So this is the specialization that has been picked up for write-ln, and at compile time it checks this, that the type that is received in the list of types has and inspects this contract. So if it's empty, if its size is empty, then it enforces. If not, if its length is 1, which is in our case, because it's an array of just one string, so we just have t of 0, and t of 0 is const char array, so this condition here. Specialization for strings, a very frequent case. And then this is the general case. So there's 3 cases. If this is, I don't know, null or something, if this is string, and then if for everything else, it just calls write function, but with an additional parameter, which is the new line terminator. But if it's called with just one string parameter, one string literal, because it was evaluated at compile time, this parameter, and it's a string literal, then it probably does some of what something of what write actually does. No, something of what formatted write does. Locking text writer. How do I go back? So W, which is a trusted standard output locking text writer, it goes put of args of 0. So args of 0 is string, and put is a method of this object, and after it writes our string, which is hello world and then a 2, it writes a new line. And then probably at exiting the scope, it destroys this object, I'm guessing. So let's step into to see what's in there. So put being a member of. Where are you? This destructor of something, and the type is locking text writer, which is a struct, which is this guy, and the function is called put. Which I don't know where it is. Okay, and put also receives a list of types and a list of parameters. This is again something that's evaluated at compile time. Evaluated at compile time. Puts each element in turn. Let's see. So if it's string, what does it do? Trusted f-write, handle to the function, the string to write, trusted f-write, which is in std.stdio package in the deprogramming language, which has the attribute trusted, and this is a C style pointer to a file, and then as parameter a list of objects, which is probably a pointer to a char buffer, 0 terminated. Where's the length? The length is here, so it's a D style const array, so not a dynamic array, a const array, D programming language style, because it has a length member. And this is the buffer, obj.ptr, and this is the file. Let's go one leap. Lock acquire. We don't have symbols in there. And probably not even source code. Yes, because this thing forwards to core.stdc.stdio.fwrite, which probably, no, I don't know, could be implemented in the C programming language or the C++ programming language or something. And we don't have source code to this, to core. Or do we? We might. Okay, so core stdc stdio fwrite. How many fwrites? Just one. So it's just a forward declaration. Pointer size t, count, and then file stream. C runtime digital Morse. The runtime import core sys POSIX. So this signature should exist in POSIX, so in the GNU C library. Okay, how do we step over this thing? So it actually wrote to a standard output. This is the put method. And then it goes put and writes another string, which is \n. Okay, so after it wrote, let's look at what's next. So it defines 3 static arrays, so 3 not dynamic arrays. 3 arrays which have their dimension, their length, so unidimensional arrays, have their dimension, their array known at compile time. That's why there's no need to write 3 in here, 4 in here, and 3 in here. Okay. 3 arrays. The dexed ID shows the local variables correctly, so there's a visualizer for not dynamic int arrays. and then calls sort, and then calls chain, and then calls chain with 3 parameters. So chain with 3 parameters, and then sorts that thing, and then writes, similar to write line, but write format line. So this extra F in name means format, which means placeholders, which means a domain-specific language for the print function. Okay, so let's see what chain does. Step into. What's this? Spans multiple ranges in sequence. The function chain takes any number of ranges and returns a chain of R1, R2, etc. The ranges may be different, but they must have the same element type. Okay. The result is a range that offers the front, pop front, and empty primitives if all input ranges offer random access, and the length chain offers them as well. If only one range is offered to chain, then type exits the picture by aliasing itself directly to that range's type. So there's a way to, if you have 20 arrays, you put them in a chain, and then you can, by asking the chain what's the length, chain will look at the length of all of those child arrays and sum their length and return that value probably. So there's struct result, there's a length somewhere, there's an empty, yes, we say there's an empty, there's a pop front, yes, says that front, the documentation says that. The length, so it returns a result of rs, which rs is what? Is 3 things. Can't be inspected in the DexHead IDE. So let's go next. So, and then there's sort, which sort probably uses the methods offered by chain, so push, pop, length, empty. Let's look into this. So stop the debugging. We can't navigate to sort, so we need to put a breakpoint in here, start the debugging, and then no, we need to step into, but and then step into again. So we're still inside chain. Chain is recursively calling it itself, or an overload of itself. Yes, a ref one. And now we're inside of sorted range. Chain sorted range sorting algorithm. Okay, so we're in the correct place now. We can put a breakpoint in here. So this is the call stack. We're inside of sort now. Sort, this is the method, the function or what it is. So return type, this is the return type, this is the function name, this is the type parameters, this is the parameters, this is compile time things, this is the docstring. Okay, so there's a less operation function or something that has a default value of a is less than b. There's a swap strategy. If we swap inside of arrays, for instance, less function, this is binary function, this converts this string to actual executable code, which will be less fun. Boggles the mind a ton in such a way that this sort function works with non-dynamic integer arrays, with dynamic integer arrays, with a list of arrays, with a list of ranges, with a chain of ranges, with etc. etc. With types that implement this limited number of requirements. So this is really generic, this function. As long as you have a swap strategy, a less, a range, and all of these conditions, has slicing, has length, has random access, has assignable elements, etc., then this function will work over the type that you give it. The compiler will create a compile time specialization for the type that you give it, and then that specialization will be used to compile the source code, the actual parameters that you give. So compile time metaprogramming. Quick sort implementation. What does that thing do? We're inside of length, the wrong place. Now we're inside quick sort implementation. So you need to be really careful, to which function you step into and over which line of source code you step over, in order to get to the implementation of all of the functions that are used in your source code, like write line and chain and sort and write FLN. So quick sort implementation is in std algorithm.sorting, which is a deprogramming language submodule of the module algorithm. Generic sorting algorithms. I have no clue what quicksort does. Okay. And now we're at the last line. That's not a comment, which is write FLN. Let's step into it. So it has a list of types, which is the first one must be a, I don't know, what? Why does it say char? Not a char, this thing. Oh, so the list of types is char and then a list of types, whereas this char is used as in char array, so for strings and not only. Okay, so the type char is actually what? \s, \n, %s, \n. So this is in fact a ANSI char, so 1 byte. This char type is 1 byte, unsigned char probably. Okay. And uses write FLN. Let's see what this thing does. Step into. So write FLN. Has a list of arguments, which is the rest of the array, or the rest of the parameters of this string, the 3 things. And this is the format. Okay, so locking text writer, and then that thing has a formatted write. Let's look at this. We don't know where formatted write is. How do we find it? This thing std format, right, so it's in another the module package module. So it's in std format. We're now in std.stdio. Okay. And says that it has these parameters. Second version takes a format strings as a template argument. Yes. Checked for consistency at compile time. So let's see what that thing does. So we're preparing to enter formatted write. So yes, in the module std.format, it's this thing which is called write. So this is a what? A module. Yeah, a submodule probably. std.format.write is a submodule of the module format, std format, with just 3 exported functions. This is how unit tests, inline unit tests look like in the deprogramming language. So unit test keyword, and then this block in here is only interpreted when you run dub test or similar. So when you run dub build or dub run, it totally ignores this block because this is the unit test block. Okay. This is not a XUnit framework. Those exist in the deprogramming language. This is the built-in unit test block in the deprogramming language. You can see the imports, and I can see the 3 exported functions. So we're in one of the 2 formatted writers. Formatted write. We're in the first one, which has a writer, a format, and arguments. Okay. Let's see where it's called. So it says formatted write, and then this is the domain-specific language of print, the format. This is the list of arguments. Just a second. Okay, so formatted write function. So let's go F11. Step into. STD format spec. Whoa. So formatted write calls format spec constructor. This thing formatted spec. This is char, this is this type, which is the type of 1 character in the string format. Percent sign. Right up to next spec. Dynamic integer width. Width as a positional parameter. Integer precision. Yeah, so they wrote by hand this domain-specific language, the implementation in the deprogramming language. Creating an implementation that can run over many types of containers, of string types, etc. Of arguments list, this thing. Okay. So this is the body of the main function, which is the entry point to the executable. This is a sequence of instructions, so a linear structure in the structured programming sense. Okay. Read in your language. Install D locally. I have it installed locally. I have configured my IDE. Run program locally. I can do this if I want. cd source, and then dmd up.d, and now it has created an up.o, so it has created a input to the linker for the linker, and then the linker has converted all of the .o files to the final executable, which is app in this case. Okay. Or we could just compile, we could just run the D file with compilation on the fly. So it both compiles and runs the resulting file. And the intermediate compiled executable is not in the current directory. If we put this shebang line at the end of the file, then we can execute the file with / and then the name of the .d file. There's a package manager which is called dub, the standard package manager. We wrote dub init, then tour. It asks some questions. Okay, when we change to the newly created directory and we run dub build, it will fetch the dependencies and build. With dub run, we'll first dub build and then run the generated executable. The list of packages that can be installed using dub. Okay, so simple hello world programs usually have a write line, and that requires imports. So we either import the entire std.stdio or we import just write line from std.stdio. And imports can be at the start of the file, but can be also in many other places, like in here. Save all, project, compile. And it has compiled successfully. Compile and run. So running tour, hello world 2, and then sort chain, what did this do? Totally did not expect this outcome. So it recreated 3 arrays of the same sizes at the input, but in the first array we have the first values like 1 and 2 and 3, then 4, 5, 6. Interesting output. And then there's a new line from here, from ln. This is the language doesn't impose arbitrary restrictions on you. Standard library is called Phobos, is located under the package standard, and its modules are referenced through import std.module. The import statement can be used to selectively import certain symbols. So in here we did import std.stdio, but we could also import just what's needed for us, which is this and probably this. Yes, it worked. Selective imports can be used to improve readability by making it obvious where a symbol comes from. So if you import multiple modules and two different modules implement the same symbol, then you might get a clash of symbols, which never happened to me. Imports match directories and files. My.cat always refers to a file cat.d in the folder my. The folder my needs to be in the current working directory or in one of the explicitly specified directory imports -i. Or could be a directory my with a subdirectory cat. And then the D compiler searches for the magic file named package.d inside of these my/cat directories instead of my/cat.d. And we can see that because in Phobos std range is the type of modules with directories and the package.d file. Whereas parallelism is of type of the first type. So under std there's a file parallelism.d versus there's a file where are you? std/range/package.d. Package.d publicly import all other modules in the same folder. So imports all of the other modules in the same directory. Let's see what it actually does. This package.d file. Public import std array, no, not this. Module std.range. Package.d. Range, yes, so in module std.range, and then it should import interfaces and primitives. public import std range primitives, public import std range interfaces. Okay, so this is said in here. The convention, but not a hard rule for package.d files is to public import all other modules in the same folder. Hello world. Basic types. Regardless of the platform, there are basic types which have the same size. The only exception is the real type, which provides the highest possible floating point precision. If the application is 32-bit or 64-bit, does not matter. The size of an integer is always 32-bit. Okay, so we have sizes in here. Int, unsigned int, dchar 32-bit, yes. We saw that strings and the backing char for the string is sometimes 32-bit, which means UCS 4 encoding. Long U-long 64-bit, short U-short WChar 16-bit, WChar for UCS2 for Windows WChar-T, and char 8-bit for Windows A and for Unix UTF-8, bool byte ubyte. Okay, and floating points, floats are always 32-bit, double always 64-bit, and real at least 64-bit. And then there's prefixes, U unsigned type, char UTF-8, W char UTF-16, so UCS2, and D char UTF-32 UCS4. Conversion between variables of different types is only allowed if by the compiler if no precision is lost. From double to float, it's allowed even though it might lose some precision. You can use cast and then type my var expression. Special keyword auto creates a variable and infers its type from the right-hand side of the expression. Auto my var v will deduce the type int. Okay, so int is preferred over short. Okay. So int is preferred. Auto means the type is inferred at compile time, and it's exactly the same thing as if you would write int in here instead of auto. Can't be changed. All data types have a property.init to which they are initialized. All integers are initialized to 0. All floating points are initialized to not a number. Integral and floating points have a max. Integral types have a min. Floating points have a .min normal property. Let's see this. So we go this, and then dot max reserved word. Could be declared const or immutable. A project, compile and run. So we can go const. Okay, so my var is 2 billion, which is signed int. So minus 2 plus 2 billion means 32-bit signed int. Okay, then there is a dot init. F10, Control S, F10. Okay, and the mean should be minus 2 billion. Okay. So floats init is not a number. Floats have dot mean underscore normal. Floats have max. There's also double dot infinity, double dot dig, double dot month underscore dig. Every type also has a string of property which yields its name as a string. Let's do that. Control S, F10. Every type has a string of property which yields its name as a string. Double. Okay. Every type also has a string of which yields its name as a string. Okay, but then why do variables also have a string of property? Index is in D. Type size underscore T, which is 32-bit. Does not say. So it's 64-bit architectures U-long, so 64-bit, and on 30-bit architecture U-int, which is 32-bit. So is a type that is large enough to represent an offset into all addressable memory, which is the size of a pointer in the C programming language. Okay, let's see that. Size underscore T, max. No. So max of size is way too large for int. So it says cannot cast oolong to int. Okay. So oolong is the biggest type that we have. That's integer. Okay. Assert is an expression which verifies conditions in debug mode and aborts, but only in debug mode. Which debug mode is this thing, the dub bit configuration. I have never ever used asserts. Okay, assignment is with equals, variables, floating point, fundamental types. See this example. F10. Okay, so it write lines 3 times. Type of f is float. Type ID of f. Then this is 32-bit signed. Int min, int max, correct. And then string of int. You can put underscores if the number is too big. So 7 million. We cast that thing to short and will create an interesting value. Let's see what the value is. So it's -12352. Seemingly random thing, because you cannot put 7 million on short. Short is 16-bit, and the size of 16-bit signed 16-bit. That's going to be really small. $32,000. So no way to put 7 million there. We can comment with // at the start of the line. The rest of the line will be commented out. We can convert the int to uint. Not really. How can we convert a negative thing to this thing? So it converts -7 million to 428 million. No. To 4 billion. It's really strange that this cast is allowed without explicit cast. Okay, int g, assert g equals 0. So yes, these will be so. G is of type int, 32-bit signed, and it's initialized by default with a value init int.init, which is 0. This 0. Okay, then it asserts that g equals 0, and since we're on debug, let's see how this thing works. Control S, F10. So it says core exception assert error. And if we're on release mode, it doesn't do anything. So this thing is ignored when you're not building as debug build configuration. Okay. So type ID of a variable says float, converts f, this final f means float. So this is float, float is 32-bit, double is 64-bit. So the conversion is okay. Then also down is okay. So we can go from double, which is 64-bit, to float, which is 32-bit. As it says in here. A conversion between floating point types is allowed from double to float. Init 0, size of 4, number of bytes. Maximum of bool is 1. Interesting. Interesting. Int mean minus 2 billion, plus 2 billion. This is the string int. Okay, next. Allows manual memory of management with pointers. Reference address of A. Auto in this case is int pointer. Manual memory management is very error prone. D uses a garbage collector by default. I didn't use these things in the D programming language, or this. So it says that even when you go like this, when you allocate just one int on the heap using new, even that is it's garbage collected, and the garbage collector will do its things, which is very interesting. So this thing will not leak memory. So the auto completion only offers me what's possible. I have just two functions possible, which is writeLine and main, if I want to call main recursively. And then I have keywords and import. And the straight module full path of an identifier. Let's see if that works. So std.stdio.writeLine. Write f. Undefined identifier std. So you cannot call write FLN with full path without actually importing the module first. Okay. Okay, so this is allocated on the heap. The heap is managed by the garbage collector. When the heap exits, when we exit the scope, there's no other reference that points to this memory allocated on the heap. So the garbage collector can free these 32 bits allocated on the heap when the garbage collector wants. Okay, there's system, trusted, and safe. The default is system. Safe is a subset of D that prevents memory bugs by design. Safe can only call other safe or trusted functions. Explicit pointer arithmetic is forbidden in safe code. Let's see what this is. Cannot take address of local A in safe function main. So not even this is allowed. Pointer arithmetic not allowed in safe functions. Okay. Trusted functions are so by default all functions are system. Functions that are safe can do a limited subset of things. So can't dereference memory, can't do pointer arithmetic, can only call other safe or trusted functions. Whereas trusted functions are functions that exist in the deprogramming language, in the standard library, and somebody has manually determined that they are as good as safe, in the sense that they will not have errors related to memory management, even though they might do interesting things like calling external C libraries, etc. Dirty underlying low-level world. So safety is a subset of the deprogramming language. When you go new int, it allocates 32 bits on the garbage collected heap, garbage collector managed heap, so there's not a problem there. This does pointer arithmetic, so that's not allowed. If we make the function safe. Pointer arithmetic not allowed in safe functions. This is how we call a function. This is how we define a function, similar to Java, C++. So it's type, return, the type of the return value, the name of the function, the identifier of the function, and then a list of parameters. If there's 0 parameters, you still must put a empty pair of parentheses. If it doesn't return anything, you need to specify void. D is a statically typed language. Once you declare a variable, its type can't be changed. Cannot. Const and immutable. An immutable object can only be initialized once, and after that it is not allowed to change. Even if you put the same value there. Ctrl X, Ctrl S F10. See the error. Cannot modify immutable expression error. ERR. Yeah, really important immutability for pure functional functions and for threading. Can be safely shared among threads with no synchronization because they can never change by definition. And they can be cached perfectly. Const can be modified too in the current scope. So most API functions accept const arguments in order to support both mutable and immutable data. Just valid for the current scope. So it's kind of like a mutable plus immutable equals const. And the literal strings are immutable arrays. Really interesting. We can declare functions in functions. ABCD and ABCD. Okay, so this is not a const but an immutable array by default. And this makes it a mutable copy. This is the way it defines a function that can either receive an immutable array string, so a string literal, but also a mutable array. So mutable takes it in. Okay, so let's see. If char array is not made const, then we can call it with an immutable array, and we cannot call it with a mutable array, immutable array. Yes, because string is immutable char array. Interesting. Says that immutable and const are transitive type qualifiers. If you apply const to a type, it applies const or immutable recursively to every subcomponent of that type, so to every data member of that type. So in order to find out the type of a variable, you use type of. And each and every variable and type has a .string of property. So type of gives you a type, but then string of converts that to the string int. It's mutable. We don't say constant. We did not say immutable int or const auto or immutable auto, because auto automatically will use int 32-bit signed for 100. For the right hand side 100. Okay. So m is mutable on the stack, and then you get a pointer to it and you store it into a const int pointer. What does that mean? Const int pointer, that the pointer is const, that the reference is const, or what's under the reference is const. Okay. Immutable v, type of v, immutable of int. Oh, const of int and immutable of int. Const may point to read-only memory, but it is read-only as well. So you get a const reference to that immutable int. It says that it's a const int pointer. Const can be modified. What cannot be modified? The ref or the integer? Everything. So you cannot modify const expression. So pointer cm or the reference, the address CM, is also const. But if I go int m2 equals 50, and then we change just the reference. So maybe that's what transitivity means. That both a reference cannot be changed, but also the memory that the reference points to cannot be changed. Okay, so up until now we only had a linear structure. Now we're at the alternative structure, if. If, else, else, if. Same as in C#, the syntax. The braces can be omitted if the block contains just one statement. Equals with two equals, equality, not equals with exclamation mark and equals, less than, greater than, less than or equal, or logical, or and logical. Okay, switch also works on strings. And you can have one case branch that handles more than one integer. So case 0, 2, this is the Turbo Pascal syntax, to case 9. Control A, Control V, F10. So if equals, if equality between the literals 1 and 1, yes, you can trust math. C space is within, so 5 is within 0 to 9. Nothing, and exactly 10. Great. Logical expressions, if statement, ternary expressions, switch and case. So the ternary operator, question mark, colon. Okay. Next, functions. We already talked about the main function, which is the entry point to the executable, starting point of every D program. Function may return a value. If it returns void, then it does not have a return value. Nothing is returned. Can have any number of parameters. Can have 0, like our main. Can have 2, like in this example. The return type is defined as auto. The decompiler at compile time will infer the type. Multiple return statements must return values with compatible types. So this is integer, this is, I don't know, double. So auto is a double. This thing is a double. And this is an int. Default arguments with the syntax that we expect. So all of the default arguments should be at the end of the list of arguments. Functions declared inside other functions. Can access variables locally defined that exist in this scope. Delegates. Such nested functions are called delegates. Why? Functions in programming, function parameters, function specification. Okay, let's see what this example does. So we have an int main, a main function, which calls a function that doesn't return anything, or we ignore what it returns. So it probably writes to the standard output, right line. And then static assert, we need to be using the debug build configuration. Traits, compiles, add 1 and 2. Let's see. So we import just right line and uniform. We declare 4 local functions that are visible here, which is strange. They're called from this switch. So it generates a random number from 0 to 3. 0, 1, 2, 3, 4 random numbers possible. Add submul div, and we have 10 and 5. So in this case, mul was called, which is case 2, because we got the result 50. 5 times 10, 50. Assert of 0. Traits compiles add 1 and 2 is false. So static asserts are compile time asserts. And are triggered even if you compile using a non-debug build configuration. Okay, so this is a function call, this is a function call. the result of this function, which is 10 divided by 5, which is 2, is passed to this function. And this is where the functions are declared. So embedded into this function, auto, which means int always in all of these 4 cases. Takes 2 parameters, each of the 4 functions, and then what's different is the operator. The operands are the same, left hand side, right hand side. Which is this and this, which are 10 and 5, A and B. Next, structs. Structs are constructed on the stack, are copied by value. So C++ style, C++ std vector style, std : string style. Auto p equals person. So this does a copy, or any assignment with structs does a copy because they're on the stack and they can disappear anytime, whereas you might pass it to another function call or something. Okay, so the syntax that we expect, similar with C#. This is also similar. What's interesting is that a default constructor is created by default that takes as parameters the values of the data members in the order that is defined, which is not okay, because who knew that the order in which members are defined inside of a struct is part of the ABI? Once you reorder these 3 alphabetically, so have age, agex, height, and then height, this line will fail to compile, or will create some interesting non-statically typed errors at runtime. So errors not caught by the compiler. Or they're caught because height is int and you assign 3 dot something to it, that will fail. Okay, so copy by value, assignments, or when you put them as parameters to function calls, constructed on the stack. You can create a new constructor with a syntax that's not what you expect, so you would expect this to be a person, but no, it's this. Okay, can contain member functions. They are by default public. They could also be private. If they're private, they're available to code in the same module. So similar to package or static or internal visibility, internal in C#. Const member functions. If a member function is declared with const, it won't be allowed to modify any of its members. If you have a member function that's declared with const, cannot edit anything in this, the parameter that it receives, and also just that. So member function will never change the state of the object. You can have const objects or immutable objects. If the function is const, it will not modify this. Okay. If a member function is static, can be called without object, so class name dot function name. Cannot access this because it doesn't receive this as parameter. Okay. Struct cannot inherit from another struct. If you want hierarchies, use classes. You can cheat by using mixins and alias this. Length returns the vector's length. Dot returns the dot product of two vectors. ToString returns a string representation of this vector. So ToString, similar to C#, will be used when you do string format. Okay, let's see what this thing is. Control C, Control A, V. Assertion failure. So we have struct vector 3 that contains x, y, z, so a 3D point in the 3D space, x, y, z tuples. And let's see what these things are. Length returns the vector's length. What do you mean by the length of a vector? Oh. So vec1 length is 10 because there's just a 10 in here. Whereas this one is 20 because summing these three is 20. Okay. But we use sqrt. So length meaning what? The distance from the origin O to the point. Yes. And that is what? In 2D space, that would be square root of x squared plus equals squared. I don't know. X times x plus y times y plus z times z. Control X. Then. Okay, so we got possibly the length implemented correctly. What does dot do? Vector of 1, 2, 3. Dot. Dot product of two vectors. So 1 times 1, 2 times 1, 3 times 1. Okay. 1 times 3, 2 times 2, 3 times 1. Okay, we can do that. And then, so this dot x times right hand side dot x plus this dot y times right hand side dot y plus this dot z times right hand side dot z. Control X, Control S, F10. Everything's perfect. Okay, so a struct contains two data fields, data members, all public, X, Y, and Z, to double to public functions or not. Let's see. Visibility. Any number of member functions can be contained by a struct. By default, they are public. Okay, so these two are public, callable from the vector, callable from the file, and callable from other files. If this were a module, this file is a module, then it can be called from other modules. Okay, we use the automatically defined constructor, which I would never use, because simply reordering these lines would break the source code silently. There's one vector3 which is called vec1, and another one which is called vec2. You can create it all at once on the stack like this, or on the stack with the default values, which means 0, 0, 0, and then assign to the data members that are not 0. So this is probably the same thing. No, it's not. Why not? Vec2 has not a number because they're doubles. That's why they're not initialized with 0 by default. That's why you need to initialize them. I thought they were ints, but they're not, they're doubles. Float and double get initialized by default with .init, which is not a number of that type. Okay. Okay, where is toString? Can implement toString. Let's see how do we do that. Do we write here string? Let's use concat. Ctrl S. Let's see, what did I mess up? These are not strings. Okay, so we really need to use string format. Let's see what string format does. std format. Immutable char array. Char format and args. And the format is what? %s. Well, and this is not %s, this is a float. Okay. And I want to print this thing. Right, FLN, right line, just right line. No. Right line is not defined. Perhaps import std.stdio. Yes. Okay, and it does what we expect. So if we want to print a thing, an identifier, a local variable, the its toString method will be called. What if we rename this thing to toString1? Yes, F10. So there's a default formatter that can convert vector3 by default or any struct to string, but we can customize that thing. Okay. Arrays. Two types, static and dynamic. Bounce checked access. Failed bounce check yields range error. You can use the compiler and specify minus bounce check equals off. In static arrays, at compile time we know the size of the array stored on the stack, or in static memory, otherwise if not defined or inside the function. Fixed compile time known length. So this is not here after the name of the variable, but after the type. The size of the array is denoted next to the type, not after the variable name, like in C or C++. Dynamic arrays are stored on the heap. Can it be expanded or shrunk at runtime? So garbage collection is used for dynamic arrays. New and size. Was that type off? And then string. Ctrl S F10. So this is int of 8. Whereas if you don't specify the size, and then you go new int of 10, it's int square parenthesis pair without any number inside. Okay. Range exception. We try to shove in a array of 8 ints an array of 10 ints. Okay. Type of ARR is int pair of square parentheses. A slides. So int with a pair of square parentheses is called a slice. Slices are views on a contiguous block of memory and will be explained in more details in the next section. Multidimensional arrays can be created using new int square parentheses 3 then square parentheses 3. This does not work. This does not work. This does not work. Cannot implicitly convert expression new int of 3. So it allocates just one thing on the stack and one number is known in compile time, which is the first 3, and the second one is not known. No? So the first one is not dynamic and the second one is dynamic. How do we make both dynamic? Arrays can be concatenated using the tilde operator. Creates a dynamic array. Mathematical operation C of 0 is A of 0 plus B of 0 with such a syntax. If you want concat of A and B, then use tilde. Do that. So type of A is dynamic int array, even if the compiler does know the size. Very often you don't guess what auto does. So you need to do things like this thing. Find out the exact type that's used. Okay, and length of C. How do we find out the size of a thing? And declare the identifier length. Provide a property dot length. Okay, so C is a dynamic array that has 4 elements. B dynamic array 2 elements. A not dynamic, so static array 2 elements. Okay, what if you write C? How does dynamic array of hint to string look like? Square parentheses 1, 2, 3 with spaces. Okay. You get the last one by identifier square parentheses identifier dot length -1. When indexing, you can use $sign symbol. .dup property creates a copy of the array. You can write to the property length if the array is dynamically to change its size. So we just removed the last index in the dynamic array C by resizing it from 4 elements to 3 elements. Okay. So let's look at this incomplete example. So this is a function, this is the main function. The function encrypt is called in here, 2 parameters, an array to be encrypted. This thing is a dynamic array. This thing is a dynamic array, but with a size that's known at compile time. Okay. And in here we can put dynamic arrays. There's no const char parentheses. And then there's a 16, which is 16, the shift. It takes the input, which might be which might be static or not, and makes it dynamic. Not really needed, but that's what it does. And then it does something with the elements in the array. Okay, right line before, so right line has any number of parameters, they put 2 in here. This is to be encrypted. We know that char array dynamic arrays have a toString default method which writes parentheses w comma space e comma space l, etc. Auto encrypted. So this is the input string to be encrypted and the output string which is encrypted. It writes that too, and then it asserts that the conversion was correct. So you can go a array equals another array. Interesting. So T and a pair of square brackets is called a slice, given the type T. Provide a view on a subset of an array of T values or just point to the whole array. Slices and dynamic arrays are the same. Okay. A slice consists of two members, a pointer to the starting element and the length of the slice. So T pointer ptr and length, which is a member of the array. This thing. If a new dynamic array is created, a slice to this freshly allocated memory is returned. So when it does new int 5, it allocates on the heap, gets the pointer to the start location, just knows the length, which is 5, it generates a struct like this, and that thing gets copied and assigned here. So it has access to length, which being a struct is public, I guess, I don't know. Actually allocated memory in this case is completely managed by the garbage collector, yes, because it did int of something new. View on underlying elements. And when I assigned 3 to the member length, then right line started at ptr and went just 4 positions in total, no, just 3 positions in total, not 4. Even though the 3 was already allocated on the heap. The stack, I don't know. We were just given this view, 1, 2, and then the second 2. Slicing operator. So this R has elements from 0 to 5, whereas in here it returns elements from 1 to 4. So 4 is not included, but not 0, so it's just 3. 2, 1, 2, and 3. 3 elements out of 5. new r of 0 is in fact r of 1. Okay, so a slice is a view into existing memory. You can apply slice to another slice, to static arrays, to struct classes implementing ops slice, and a few other entities. Okay, this 4 is not included. We don't copy. I do this assignment. It's garbage collected when no references exist to the actual memory on the heap. It can be garbage collected. So if you have just one giant memory block and you keep iterating on it without actually editing it, just read various parts of it, various views into that memory block, parsers, for example. No need to allocate new memory blocks. Okay, you can use the $sign inside square parentheses for the array length. Okay, let's look at one example. So what does it do? So this is an array of type dynamic integer. When you say test dot writeLine, it's in fact writeLine and square parentheses test. So uses the default format, the default toString method of int array dynamic. First element test of 0, last element $-1. Okay. Exclude the first two elements. So slice from 3 including 0, 1, 2, 3, so 7 to $sign excluding, so $sign would be this, so to this, from 7 to 6. Exclude the first two elements, so it starts with 2, which is 0, 1, 2, this thing 11, and ends at $-1, which is 6, so this part. $11 through 6. Okay. And then test2 equals test, subview test. So test contains everything. It's the first thing that we writeLine here. we should start with 3. All of the elements were incremented. All of the elements in test were incremented by 1, so 3 becomes a 4, 9 becomes a 10, so 4, 10, and so what it says in here is that you can see that 4, 10, 12, 4, 10, 12, and 8, 3, 7, 7. So 3 different variables point to the same place in on the heap in memory, but just different views of that memory. So just starting with this index, this many elements, or starting from that index, that many elements. So all 3 are backed by the same memory, so when it changed all of the values at all of the indexes, then what's visible here, here, and here changed automatically. Okay. So a slice of just 0 objects, because it starts at index 2 and ends with the index 1. So it's this descending from 2 to 1 is in fact 0. If it were from 2 to 3, so that would be 2 and up to 3, but excluding 3, so that would be 2 from 2 to 2. So that would be length equals 1. Two new constructs in one line. Alias string is immutable of char array. The term string is defined by an alias statement, which defines it as a slice of immutable chars. I don't know, how do we do that? So string is an alias, but when you go string off, it tells us the name of the alias, not the name of this right-hand side. And it's char, so 8-bit, which means UTF-8. UTF-8 string, so it's not a D char, which is 32 bits, 8 bytes, UCS4. It's actually UTF-8, 8 bits, 1 byte char. And it's strange that it's not unsigned char. Why is it char and not unsigned char? Okay, so they're immutable, shared perfectly amongst threads. String is a slice. You can look at parts of the memory. STD algorithm splitter splits a string by new line without any memory allocations. Okay, there's 2 other aliases. UCS2 UTF-8 W string, Windows style, And UTF-32, this string, I don't know what this thing is. Java style, Qt style, I don't know. UCS4. I don't really use this. And this I would use when I interact with Windows Win32 APIs that end with W. To dstring, to string, stdconf, there's a to method, and this is a list of parameters. And this is another list of parameters. Okay, let's do that. Okay, and it says that the template instance to of list of types dstring is not defined. So we need two, which is from stdconf. Okay, let's run it with a debugger. Okay, so stdconf, the module, one-stop shop for converting values from one type to another. Module stdconf. And template 2, which template means a class. To and then specializations by dstring. So a length different than 0, because why? The type is dstring. The length of this string is not 0. What even means to the length of this string? Okay. Control S F10 and then debugger. To impel of T. Implementation of 2. Well, what is this? To impel. Again, a method that accepts a function that accepts all sorts of types which have some traits like is exact sum string, is null to string, is infinite, is enum string to string, is implicitly convertible, T and S. What is S if this is T? Returns w.data, string to string. Std array appender. The amount of genericity needs to trickle into a ton of functions in the standard library to support different types and types with different traits and the existing of certain methods on a type, etc. Pop front items. Std range empty. If is type of a.length is size t. Wow. Auto decodable string. dchar. Front. So there will be some UTF-8 to UCS4 conversion, which can only be done correctly using a really fat library, system library like ICU or the Win32 function that converts between char sets. And it writes test. So A is 8-bit, whereas ASD string is 4-bit. So the letter T stays on just 8 bits, 1 byte, whereas for the D string, the letter T takes T, a \0, another \0, and a third \0, so 4 bytes. Okay. Again, this is a function, whatever, not a function, but okay. And this is a list of parameters of type, list of type parameters, and this is the list of arguments. Okay, Unicode strings, graphene, code points. I have never done such a thing. Neither this. Be really careful when you do s.length. What does it really do? Code unit. Okay. Multi-line strings. I'm not sure why they implemented such a feature. F9, F10. This may be a long document. And the debugger. Okay, looks great. So insert \n. YC weak strings or HIRDOC strings. Raw strings with backticks or with a raw prefix. Copy, Ctrl A, V, Enter, Ctrl S, F10. My string hello world. With O with 2 points. Array length code unit 13. So how many bytes actually exist in this UTF-8 string? Code points, whatever that is. I don't know what that is. And character length with graphins. So this is probably how many what humans would reply to the question how many characters are in the string hello world with special O's. Okay, string replace. Replace this is the first special O with a simple O. Imports replace, then it imports ends with and asks if it ends with RLD. And responds true. So the boolean true when converted to string actually is lowercase t r u e. Okay, and into this string, and WriteLine has an overload probably for these strings, such that it can do such a thing. Okay, next. So we had linear structures, then we had alternative structures, if and switch, And now we have repetitive structures or loops. There's while, there's do while, and there's for. And then there's for each. Break exits in the current loop, and you can use break with a label. Don't do that. The keyword continue, as in other programming languages. Okay, what does this thing do? So there's a two-dimensional array. It iterates through the first dimension, and it writes the average of testers of y. So this is an array, a single dimensional array. It has an automatic conversion to string. The average of, and is this. And then it writes space equals space. And then there's the average function, which is implemented in here of this array 5 and 15. Single dimensional. So average receives a slice of int, which is a dynamic int array. So it remembers the initial length, uses a floating point accumulator, and iterates what does it do? So array of 1, array of 0, which is 5 in this case. So okay, and then it overwrites array. So array becomes a slice to another thing, a slice to a slice to a slice to a slice, but no memory copy happens. We just ignore the first element in the array, which is 5, and go to the next one, which is 15, and let's stop at length of array minus 1, which is we stop at the last one. So we have a new array, which is a slice, which has the identifier array and has just the value 15, and it does 5 plus 15, and it's 20. This becomes empty. This does not have a length, so it jumps out of the loop, and then it goes 20 divided by 2, and that's 10. Interesting. This is the classic C, C++4, even better with a pre-increment. A for each loop allows for less error-prone and more readable iteration. Given an array R of type int, so a slice of int, it's possible to iterate over the elements using a for each loop. So E is the local counter, the local variable inside of the for each iteration, and this is the array. So the first parameter is the name of the variable to be used for each iteration, and there's semicolon. Its type can be inferred automatically. type of e is int. Okay, write line e. The second field must be an array or a special iterable object called a range. Okay, with op-range operator or something. Access by reference. Elements will be copied from the array or range during iteration. This is acceptable for basic types, but might be an error, might be a problem for large types. Ref can be used to prevent copying or to enable in-place mutation. Iterate n times. So we declare a range in here, or what's this thing? And then the local variables goes to from 0 to not 2, to not 3, to the value that's before 3, so 0, 1, 2. Okay. Index counter, you can specify more than just one variable, you can specify two variables. So the first one is the index counter, and the second one is the actual local variable. So there's 0, 1, 2, and the actual local variable is 4, 5, 6. For each reverse, then, so what does it do? Two-dimensional array, both the index counter and the index variable. It uses the counter to write here row 0, 1, 2, and it uses the actual row. So 5.15, this is the first value for the row variable. Goes for each, iterates through 5 and 15, and the sum is 20. Then it divides 20 by a row which is this thing, length which is 2, so 10. So another way to do average in two-dimensional arrays. So for eaches are sugar syntactics over something like this pseudocode. Auto arrange copy is arrange, not arrange copy dot empty. So I'll not arrange copy dot empty. Arrange copy pop front. Auto element is arrange copy dot front. So this is a either a type that has these operators and functions, methods, public members, and then this could be a slice. So this is another slice. And then not empty, we know how it works. Pop front probably changes the range but doesn't the copy of the slice or the view into the memory data, but the memory data stays unchanged. And then we get from the memory what's at this position in the array slice. Any object that fulfills this interface, so empty, pop front and front, is called a range or an input range. This is a type that can be iterated over. Input range of e element type, bool empty e front, void pop front. Ranges are lazy. They won't be evaluated until requested. Hence, a range from an infinite range can be taken. So again, 42, repeat, which is infinity, and then take 3, which will lazily take just 3. So using a syntax such as yield in C#, and then write line. Because write line, in fact, is a function that takes one parameter, which is this thing. Value versus reference types. If the range object is a value type, then a range will be copied and only the copy will be consumed. If the range object is a reference type, class or stdrange ref range, then the range will be consumed and won't be reset. So we get a stdrange ref range of the array 0 through 4. When we go drop 5, it actually has changed the R2. Input ranges are forward ranges. Most of the ranges in a standard library are structs. So for each iteration is usually non-destructive, though not guaranteed, because its value type will be copy on construction, or copied, and only the copy will be consumed, and structs are value types. Interface forward range is an input range with an extra method that's called save. The same type of this. So you get a reference range, then you save it by decoupling the storage of R from the storage of R2. And then you can drop 5, write line, and then you write whatever is in R. Bidirectional range, E back, avoid pop back. or forward range. Retro. A random access range has a known length and each element can be directly accessed. Op index and length. Array is a random access range because it has a length and an op index. And from forward it has save, and from input range it has empty front and front. So ranges enable the creation of lazy objects that only perform a calculation when it's really needed, such as the pipe vertical bar operator in Unix POSIX shell. Okay, std range, std algorithm. Fibonacci with pop front and empty, because the Fibonacci range never ends. Remove the first element. Return the first element. Keep take 10. Drop 5. Filter, so all of this smells like C#. C# link you. Okay, associative arrays are hashes, hash maps, dictionaries. Key of type string and value of type int. Accessed in the sense of attribute assignment. If key 1 in R turns a pointer to the value if it can be found, or a null pointer otherwise. So you can go if auto_val equals, because assignment returns the value of the left-hand side, the final left-hand side, which if null, if will fail. Access to key which does not exist yields a range error. So don't do this if you don't know for sure that key 1 exists. Get key default value can be used. Dot length property. Dot remove val member. So removes all of the entries with this key. By key and by value ranges. Takes text, converts it to lower, splits it by space, so rock D with D for each. So rock becomes words of W++. So 0 words of 0, so rock, lowercase, and then plus plus. Ctrl S, F10. Let's look. So for each rock D with D, there's a words dictionary with strings. So rock increment by default is the values are 0 because they're ints, and their dot init is property is 0. So there will be at the end, words will have 3 elements: a rock with the value of 1, D with a value of 2, and with a value of 1. Okay, in here we have 2 elements in the for each: key and value. So key D, value 2, rock 1 with 1. Okay, this thing. And then words dot keys. Okay, 3. Words by value. So words by value, interesting. So it returns 1, 2, and 1, and it sums that entire thing. So sum receives a range, which is this thing, which is similar to an array, and it can iterate over it and sum it. So the result is 4. 1 plus 2 plus 1. So we have an array.group key value. A3, B2, C1, D1, E2. So this group thing creates a tuple of dchar u int A3. So why is it a dchar, not a char? Okay, in the associative array, key value dot a sock array. D1, E2, B2, EU, C1, A3. So it converts a array of tuples into a dictionary. So any class inherits from object implicitly, such as in C#. This is how you specify inheritance. Instantiated on the heap using new. A reference type aren't copied by value. Both point to the same thing in memory. The garbage collector will make sure the memory is freed when no reference to memory exists anymore. Keyword override. Classes can only inherit from one class or no diamond. Problem. Final and abstract member functions. Final to disallow overriding it. Abstract to force derived classes to override it. A whole class can be declared as abstract. such that it can be instantiated. Super explicitly call the base constructor. Compare the contents of the objects. Comparing her against null is invalid, as null has no contents. The is compares for identity. So C is null, C exclamation mark is null. For struct object or bits are compared. For other operand types, identity is the same as equality. Any and an integer inherits from any. Super integer, which is a constructor with type string. Protected is just seen by inheriting classes. Final public is implicit in classes, which is interesting. Abstract, convert to string, override to string of number. Float inherits from any. Different precision. Okay, interfaces. Technically large class types, but whose member functions must be implemented by any class inheriting from the interface. Animal make noise. Make noise behaves like an abstract method function in a base class. So you must use the keyword override. Implicit cast to interface. When you convert a dog to an animal, which animal is an interface? It may implement any number of interfaces, but it can inherit just from one class. So you can have final non-overridable functions in an interface. Okay. Next, templates. D allows defining templated functions similar to C, C++, and Java, which is a means to define generic functions or objects which work for any type that compiles with the statements within the function's body. Add T, so this is the list of types, and this is the arguments list. Template parameter list. Set of parentheses in front of the actual parentheses. T is a placeholder which is replaced by the compiler when actually instantiating the function using the exclamation point operator. So add instantiated of int, of float, of animal. animal doesn't have this plus. Function templates have two parameter sets. The first is for compile time arguments and the second is for runtime arguments. Non-templated functions can accept only runtime arguments. If one or more compile time arguments are left unspecified, when the function is called, the compiler tries to deduce them from the list of runtime arguments as the types of those arguments. T is deduced to be int. T is deduced to be float. Okay, interesting. A function can have any number of template parameters which are specified during instantiation using func syntax. Template parameters can be of any basic type, including strings and floating point numbers. Templates are compile time only, yield highly optimized code tailored to the specific set of types used when actually calling the function. Struct class interface types can be defined as template types too. Okay, so what does it do in here? It has a animal, it has dog which inherits from animal, cat which inherits from animal, but animal is called with this thing, which means that it's a template class. What do you mean by template class that allows generic implementation of animals? That's because this is not a class. This is a function. So the name of the function returns a class and has one argument. It returns a class that contains a void make noise, write line noise, which noise is this thing. And that class is then inherited from here. Oh, mama. Oh. So without this, it's just a class declaration. Class and a method. But then you don't have access to noise. Template class. Okay, and this is another function, which is a function that has two sets of parameters. The one is types and the second one is arguments. So the type T is taken from the first parameter, multiple noise dog t. So t is now a distinct dog, and says 5 times, so from 0 to 4, animal dot make noise, which is woof, and then exclamation point. And that with right line, so there's a ton of new lines. Functions as arguments. A function can also be a parameter to another function. This is a function, and this is the signature of another function. And it even has a name. So this is the arguments list of this function. And this is the signature of the first argument, which is a function. Whatever function is. Delegate. Which delegate? What is delegate? Anonymous functions and lambda. Functions can be saved as variables passed to other functions. It is laborious to give them their own name and to define them. D allows nameless functions and one-line lambdas. So this one line is sugar syntactics for this. One, two, three, dot reduce, and then a function which is given as string source code. String functions use A as the first and B as the second argument. Can have maximum 2 arguments. Exceptions. Try catch. Yeah, sounds familiar. While exception, string, exception finally. Scope is better than try finally. Which scope is what? Scope exit, scope success, scope failure. 3 types of scope. When you say scope exit, do that. Scope exit, do that. Scope exit, do that. Scope exit, do 3. Custom exceptions. Inherit from exception, create custom exceptions. Okay, what signature does an exception have? There's user exception and system errors. Don't ever catch system errors. Okay, catching exceptions. To validate potentially invalid user input. Okay. No throw. You can't throw exceptions if the function has no throw, and the decompiler statically forbids this thing everywhere. to all of the functions that are called by this function, which is not row. For templated code, the attributes are inferred automatically. Don't even need to write no throw, it will be generated automatically. Asserts and contracts are removed when compiled in release mode. STD exception provides enforce that can be used like assert but throws exceptions instead of assert error. Great. Collect exception. Collect exception, a dangerous operation. We catch E, and then if E, then we write. Okay, and the exceptions have conversion to string, automatic. I can see it in here. There's e.msg, e.file, e.line, e.info. Stack trace is e.info. File, the compiler time, source code line, file, and the line where this thing was thrown. Okay. This book, Programming in D by Ali Chehreli. Okay, so that was it. That was me following the https://tour.dlang.org, which is the official tour of the D programming language. Thank you.